Hello, ladies and gentlemen. My name is Bodiujaman Pranto, and I welcome you to my presentation. In this presentation, I will be presenting a project named Sentiment Driven Spotify Music Recommendation. This project was conducted during an academic course named Methods of Advanced Data Engineering under a master's program at Friedrich Alexander Universität Erlangen-Nuremberg. The presentation has been divided into the following sections. First, I will introduce you to the project's main concept and the main goals of the project, and then we will together work through the datasets used in this project. After that, we will see the methodology followed by this project and the ETL pipeline of this project. I will try to explain how I constructed the ETL pipeline for this project and how the pipeline benefited the project. Later on, I will explain the pre-processing, data pre-processing I have conducted for this project. And then we will see the recommendation engine algorithm, how the algorithm was constructed and how it works to recommend music to the users. And then we will see the results and try to draw a conclusion. And finally, we will see some demonstration of the project. So, as the name suggests, the project aims to redefine the personalized music experience based on the sentiment extracted from users' social media post and also by considering the user's previous musical tastes. Um, I have trained a simple logistic regression model to be specific on Twitter post to extract sentiments, and the model showed 76% test accuracy. To be specific about the project's goal, there are three main objective of this project. The very first one is to have a trained model that can detect sentiment from social media post. And the second objective is to integrate users' playlist to the system so that we can have um, a idea about the user's musical preference. And the third objective is to develop a recommendation engine that considers both the user's sentiment extracted from the social media post as well as the user's musical preference to recommend new music to the user. Two datasets have been used in this project, and both of the datasets are open source datasets and collected from Kaggle. The first one I'd like to talk about is Sentiment on 40. This dataset was used for training and test purposes of the logistic regression model. There were 1.6 million tweets in this dataset and couple of attributes, but I have only used target and text attribute, where target represents the sentiment and text represents the tweet itself. And the second dataset is called Top Spotify Songs 2023. There were 943 songs in this dataset, and this dataset was used to recommend music to the users primarily. But within the scope of this project, I didn't connect it to a real user's Spotify account and extracted the playlist from the user. But for demonstration purposes, I have randomly choose 10% of the Spotify Songs 2023 dataset to use as users playlist. So to be exact, there were 82 number of songs in our dummy users playlist. So this is the methodology followed by the project. We have two ETL pipelines that extracts, transforms, and load the datasets to a SQLite database. And later on, the Twitter dataset was pre-processed and split it into train and test data. 80% of the tweets were used as training data, and 20% of the tweets were used as test data. The logistic regression model was trained with the training data and evaluated with the test data. Once we have the best performing parameter for the logistic regression model, the model is ready for detect the sentiment from new tweets. So the logistic regression model takes a tweet as input and detects the sentiment from the tweet. As for the song recommendation engine, the engine takes three things as input. The first is the sentiment detected from the tweet, and the second input is the user's playlist, and the third input is all available songs from the database. And then the song recommendation engine does some calculation to recommend music to the user, and finally outputs the recommended songs. We will see the algorithm of the song recommendation engine in the later part of the presentation, as mentioned before. So these are the ETL pipelines that have been used to extract, transform, and load the datasets in the database. I have used a open source Python package to construct this ETL pipeline. This package was also built during the course. Um, Please feel free to have a look at the repository and our work. Also, feel free to contribute to the open source package. If you like our work, please give a star to the repository as well. So, for the Twitter pipeline, it extract the dataset from the source, and in transformation step, it cleans up the text for the model training, and then finally loads the dataset in the database. And for the songs pipeline, it also extracts the dataset from the source, and then in the transformation step, it only drops the null values from the dataset. No other transformation was required. And finally, it also loads the dataset in the SQLite database. The pipelines were executed in a queue, but to be honest, the queue didn't bring any benefit to the project. It would be very interesting if in future I could run these pipelines in parallel. So these are the steps that were performed in Twitter transformation. Um, so a raw tweet was cleaned in several steps to be suitable for the model to train. So most of the pre-processing was done in this step, and it took approximately 30 minutes to clean up all 1.6 million tweets. Since most of the pre-processing were performed during the automated pipeline, these are the two pre-processing that were performed manually just before training the model. The tweets were tokenized, and then the text were transformed into a numerical format just to make it suitable for the input of machine learning models. So as for the algorithm of recommendation engine, um, it gets the user sentiment from the train model in its first step, and then get the songs from the user's playlists that aligns with the predicted sentiment. Then in the third step, it calculates the average values of audio features based on the songs selected from the user's playlist. And the audio features means the BPM, danceability, energy, acousticness, instrumentalness, liveliness, and speechness. These are the attributes that are in the dataset of Spotify music. And in the fourth step, it exclude the user's playlist from all songs, so that in the recommended songs, we do not get any songs that are already in the user's playlist. In the fifth step, the algorithm filters the songs from the from the step 4, whose valence aligns with the predicted sentiment, and the average values of audio features are in between the calculated values plus minus 10 in step 3. So the valence is the feature that determines if the song is positive or negative. It is also a feature in the Spotify song dataset. Sixth step, the algorithm orders the song selected songs by a random audio feature, and in the seventh step, it returns a random song. This is the evaluation result of the logistic regression model, and as for the simple logistic regression model, the result seems convincing and pretty useful. To get the best performing parameter, I have performed a grid search CB search algorithm on the logistic regression model, and the best parameter I found was this elon ratio 1, max iteration 1000, and the solver is Saga. And this is the result of the song recommendation engine, and the result also shows that it is convincing and it performs as expected. Now let us have a quick demonstration of the project. So if I now run my project, and then it will ask me for a new tweet. So if I write um, a fresh morning with a delicious cup of coffee. So it says this tweet has been detected as a happy mood. So it says it seems like you are happy. So the song by this artist released in the year of 2021 may align with your mood. So if I again write this tweet, it will the system will suggest me a new song. So the songs are selected in a random basis. Let's try something else. um, People are losing their right to speak. Now it says this tweet is a sad tweet, so seems like you are sad. The song Street Life by this artist released in this year may align with your mood. So the presentation ends here. I thank you all for being with me and listening to the presentation. Thank you.